All right, good evening, viewers. Today I'm bringing a new topic to you. Definitely, today we're going to be learning the derivation of the formula for finding the sum and the product of roots in a quadratic equation. All right, so today we are going to be working on the derivation of the formula for finding the sum and product of roots. But before then, I want to take you back to the general form of the quadratic equation. This is an equation, right? It is an equation of what type? A quadratic equation. Why is it a quadratic equation? Because the highest power of the variable there x is what? Is 2, right? Good. Now, this equation right here, in our previous class, I taught you how we can solve this equation using the completing the square method, and we were able to derive the root of this equation. And the root of the equation, why solve with the completing the square method, we have minus b plus or minus square root of b squared minus 4ac divided by 2a. So these are the roots of this equation. When we solve this using what? Completing the square method, we can have that x is equal to these roots. Remember, we have two roots here. We have two distinct roots here. The first root with plus, the second root with what? Minus. Now, while deriving the sum and product of roots, we consider these roots of this equation. We call the first root, we say let the first root be alpha. So let alpha be minus b plus or minus, sorry, plus, because I told you that the plus is a different root while the minus is a different root. So let's just say alpha represents the first root, which is minus b plus square root of what? B squared minus 4ac over 2a. That's the first root. Now let us use beta. I hope you're seeing the board. Let us use beta to represent the second root. And let the second root be what? The minus. So we have minus b minus square root of what? B squared minus 4ac divided by 2a. Alright? So these are the two distinct roots. The first one for alpha, the second one for beta. But then again, remember that the first thing I plan teaching you is the derivation of sum of roots. So when we say sum of roots, in general mathematical terms, sum means addition, right? So sum of root, you're considering alpha and beta, right? So sum of root means the sum of alpha and beta. So sum of roots will become alpha plus what? Beta, right? Okay. So now alpha plus beta, we already have the root representing alpha and we already have the root representing beta. So when we say alpha plus beta, it simply means the addition of these two distinct roots. So I'll clean here right now and then I'll take you through. So just like we said, alpha plus beta. Now alpha plus beta is the summation of these two distinct roots. But I want to remind you of something. I want to remind you of something, that this b square minus 4ac is called discriminant, right? Good. I hope you recall. It is called what? Discriminant. So why not represent b squared minus 4ac with d? It will help us. So let's substitute b squared minus 4ac with d. So that means anywhere we see b squared minus 4ac now, we'll replace it with d. So now in the first root, remember the alpha, we have minus b plus, right? Square root of what? B squared minus 4ac. So we're here that we have b squared minus 4ac now. Let me now replace it with d divided by what? 2a. Are we there? Okay. I will clean here right now. Plus. Remember I say alpha plus beta. This is representing alpha plus beta now. Beta we have minus b minus square root of, I will still replace the discriminant with d divided by what? 2a. Now, ordinarily this is addition of fraction. This is addition of fraction, and what we apply here in solving is, first of all, we consider the LCM of the denominators, right? So the denominator we have here is 2a and 2a. So what is the LCM of 2a and 2a? Of course, it is 2a. So I'll write 2a. Now 2a divided 2a will give me 1. 1 times everything here at the numerator will still give me the same thing. So 1 times minus b plus square root of d will give me minus b plus square root of d. I would apply the same thing here. 2a divided 2a will give me 1. 1 multiply the numerator will still give me what I have at the numerator, which is what? Minus b minus square root of d. Now at this point, what I need to do is for me to collect my what? My like terms. So by collecting like terms, I see that minus b and minus b are like terms, and sort of d and minus sort of d are like terms. Please, while doing this, remember to bracket this to separate the expression that you have. Okay, my bad. Sorry, I did not introduce it earlier. So now, collecting my like terms from here, we can have minus b will give me what? It will give me minus 2b. Then here we have plus sort of d minus sort of d plus sort of d. But let me put it together first before applying. Okay, because I believe we all are learning. So let me put this together first. So I have minus b, right? And then I have plus sort of d minus sort of d. So I have been able to collect my like terms together divided by what? 2a. Please, I hope this is clear. All right, so let's proceed. So at this point, minus b will give you minus 2b, of course. So we have minus 2b. Then sort of d minus sort of d is 0, because it's just like saying 2 minus 2 is 0. So sort of d minus sort of d will give you what? 0. So we don't have sort of d right now. So divided by the denominator part, we have 2a. So at this point, when you look at 2 and 2, you see that 2 is common and they can cancel each other. So what do we have left? We have minus b over a, formula derived. So with this minus b over a, we'll be able to find the sum of roots in every quadratic equation. I will still take you through that. I will still teach you how we can use this to find the sum of roots in quadratic equations. Now, the next thing we are going to consider right now is the product of roots. You can put this down, product of roots. So we are doing the same derivation with the same terms that we have. So when it comes to product of roots, in mathematics, product means multiplication. So product of roots, we will refer it back to the alpha and the beta root we already have. So product means the product of alpha and the product of beta. So what is product? Alpha times beta, and alpha times beta will give you what? Alpha beta, of course. So we have alpha what? alpha beta. So what is alpha beta? Remember that we already have the roots of alpha and the root of beta. And I once told you that the b square minus 4ac there will replace it with what? D, because it's a discriminant. So we can see that alpha now here is equal to what? Minus b plus square root of what? This discriminant now, I will replace it with d. I am coming. Okay, so replace this with d, right? Remember it's b square minus 4ac that I replace with d divided by what? 2a. Are we good? So this root is representing the alpha root, right? Good. Multiplied, because we are multiplying the two roots. So multiplied by beta here, where we have minus b minus square root of d divided by 2a. Okay, so to make it more understandable, let us just bracket it. Okay, let's bracket this and let's bracket this. So bracketing it means that we'll multiply using this bracket to multiply this bracket. Okay, so minus b times minus b will give you what? Because minus times minus in mathematics is plus. So minus b times minus b will give you what? It will give you b squared. Are we good? Okay. So now minus b times minus sort of d will give you plus b sort of d. So have plus b sort of what? D. Right? Good. Now what about this? We'll have sort of d. So this, remember the first thing we did is to use this minus b to multiply this, and also to use minus b to multiply this. So we are done with minus b. We consider the sort of d. So using this square root of d to multiply minus b, of course we have minus b sort of what? D. Are we good? All right. Now square root of d multiplied by square root of d, square root of d multiplied by, remember the place sign, minus square root of d. So when this multiply this, we have minus square root of d squared. Let me just put it this way, but of course you know that the answer to this is d. Sort of d multiply sort of d, the answer is d, because the square root of d squared is d, right? So I want to make it clear before I write. So I can clean here now and replace it with d. Okay, divided by 2a times 2a, that the denominator part. 2a times 2a will give me 4a squared. Very good. So we have 4a squared. Okay, so at this point I think I'll move it up. So let me clean this up. Okay, so I will move this up right now. So please concentrate on this, right? When we look at this right now, you see that we have b sort of d here and we have minus b sort of d. Of course, b sort of d minus b sort of d is 0. Okay, so this is 0 already. So what we have left is b squared and minus d, right? So b squared minus d from what we have divided by what? 4a squared. Now, I want you to recall that this d here, we substituted b squared minus 4ac for d. So at this point, you have to resubstitute back b squared minus 4ac for d. So what we have to do now is we say substitute b squared minus 4ac for d. In that case, please look clearly. In that case, we can have b squared minus brackets. Wherever we have d now, we put b squared minus 4ac, right? Good. We bracketed it because because we are trying to separate it properly. All right. Now, this bracket here means that the minus here is supposed to affect whatever thing we have inside this what bracket. So take note. The denominator part will have 4a squared. So I can clean here right now. So at this point right here, minus multiply b squared will give you what? Minus b squared. So let's rewrite. We have b squared minus times b squared, we have minus b squared, minus times minus 4ac, we have plus 4ac divided by what? The denominator, where we have 4a squared. Now, of course, mathematically, why? We already know, you know that b squared minus b squared is what? 0. Everybody say 0. So this is 0, right? So eliminating this already, what do we have left? We have 4ac divided by what? 4a squared. So this is where we just do our division. We'll just apply our division. So looking at this here, 4 can cancel out because they are common, right? Good. And when we look at here, you see that we have a square here and we have 1a here, so they can cancel each other. So a cancel out and a goes into a squared. We have a. In the end, we have c over a left. So that means the product of roots is equal to c over a. Right? So with c over a, we can find the product of roots in every quadratic equation. I believe with this, just for you teaching, you've been able to at least understand how you can derive the sum of roots and the product of roots. And I hope you enjoyed the class. Have a nice day. Thank you.